Assalamu alaikum. Welcome to lecture number 36 for the subject of software design and architecture ITech 4129. I am your course instructor Fahad Anwar. So students, before I start my today's lecture discussion, I would like to give you a little bit recap about our last lecture. So students, in this week actually we are discussing another software reuse landscape, aspect oriented programming, and in our last week we discussed in very detail about aspect oriented programming, where we see how aspect oriented programming actually deals with the shortcomings of object oriented programming. We also see how aspect oriented programming concerns towards the aspects as well, and we see aspect oriented programming in very detail, and we also see how it focusing on the principle of don't repeat yourself, which is an acronym for DRY. And then we see what are actually aspects we discussed in very detail, and then we see different aspects of different applications in today's world, like logging, transactions, configuration, performance, security. So these are the different aspects of different applications in today's world. And then we see the main difference between aspect and class, and we see in what points these two terms are actually difference from differentiating each other. And then we discuss some core aspect oriented programming concepts, where we see what is actually aspect, proxy, weaving, joint point, target object, products as well. And we also discuss the concept of advice, where we further see the five different types of advice. We also discussed before, after running, after throwing, and around advice. So it's a little bit recap about our last lecture, what we have been discussed in our lecture number 35. So students, let's formally start our lecture number 36. So students, here are the objectives of our today's lecture discussion. We will see about more details aspect oriented programming, where we also see what are the different divisions among different concerns, and we will see cross-cutting concern with the help of some examples as well. And then we see how object oriented programming and aspect oriented programming are similar or different from each other with the help of some example as well. And then we see some advantages or justifications for utilizing the aspect oriented programming, and at the end of our today's lecture we will also see some shortcomings or some disadvantages of aspect oriented approach. So here is a brief objective of our today's lecture discussion. So first of all, aspect oriented programming we are actually discussing from our last lecture. So students, now we discussed this aspect oriented programming in very detail in our last lecture. So before I start, I would like to say why we start aspect oriented programming. So the only problem with object oriented approach is that it is essentially static, and a change in requirement can have a profound impact on development timelines. So to deal with this issue, we actually moving towards the aspect oriented approach. So this aspect oriented approach, we can say, actually complements to object oriented programming. So we are not going to replace object oriented programming. Instead of this aspect oriented approach is basically, you can say, a complement to object oriented approach. So let's discuss some kind of different terms being utilized in this aspect oriented approach. So the first one is about concern. So students, what are the concerns? We already have been discussed in our early lecture. Now in this lecture we discuss this term in more detail. So students, what are basically the concern? So concern, we can say, is a feature or essential operation that should be a part of larger program or some solution. We simply call it a concern. So the concerns, we can also say that, like a specific requirement or consideration that must be addressed in order to satisfy the overall system goal, we call it concern. So what different types of concerns can be, like, for example, I choose a banking system. What kind of concerns can be for banking system? For example, customer and account management is a type of concern. Interbanking transaction is a type of concern. ATM transactions, persistence of all entities, transaction integrity, authorization of access to various services, logging, security, error checking, and different policy enforcement. So these all of these are different examples of concern in banking system domain. So the next term is code entanglement. So what does it mean? So entanglement mean to notes with someone, like we can say code or a program which cannot be separated into more than one concern. We call this term code entanglement. So it is a pretty straightforward. I don't need to give you more details about code entanglement. So simply it cannot be separated into more than one concern. So now cross cutting concern. So we are moving towards a cross cutting concern. So students, before I moving towards the cross cutting concerns, here above we discuss concern, and we also see a banking system example as well. So before I start this concern, there are basically two type of concern. The first concern we call a core concern, and the second type of concern are called cross cutting concern. In core concerns, actually central functionality of a business logic are actually addressed. Like in the banking system, we can say customer and account management, interbanking transactions, and ATM transactions are our core concerns, which actually depicts the functionality of our system. If we talk about cross-cutting concern, the cross-cutting concerns are another type of concern. We can say that a concern which is actually entangled with one or more other concerns we called cross-cutting concerns. So these cross-cutting concerns are basically system level or system level or peripheral requirement, etc. So cross-cutting concerns are basically, we can say, are some are our non-functional requirements, or they are more related to quality requirement. They are more related to quality attributes or quality requirement, like logging, authentication, performance, security, reliability. All of these are different types of cross-cutting concerns, and these cross-cutting concerns are actually related to quality attributes, which we also call non-functional requirements, and these are achieved with different cross-cutting concerns for any application or any system. So what kind of concerns can we have for any application or system? So students, we discuss concerns in very detail. There are basically two type of concern: core concern and cross-cutting concerns. So these core concerns are actually providing us the functionality of a business, while cross-cutting concerns are the quality attributes or non-functional requirements for a system. So in general, there can be different level of concerns. What kind of concerns can be? For example, I say like concerns which can be achieved at a system level, or we can say system level or peripheral requirements, or multiple modules can be logging, transaction, security, pooling, caching. All of these are different kind of concerns. So basically logging is actually we use this logging in the reliability, quality attribute, and authentication and authorization are actually related to security concern. If we talk about the buffering, pooling, or caching, these are actually concerning towards the performance attribute or performance quality requirement. So exception handling, as we discussed earlier, is a mechanism there is a mechanism for exception handling in object oriented programming, where we use some try and catch blocks to catch and throw some kind of exceptions. So all of these are different types of concerns. So in these concerns are these are the different concerns which are we actually utilize. These different kind of concerns actually as stated here, like logging, security, transaction, profiling, caching, or pooling. These type of concerns, students, are usually achieved at system level. So in aspect oriented programming, we can say these are the most important concerns. So like we discuss all of these concerns in more detail in our coming slides or coming lecture as well. So if I so for example, if I give you some example about these cross-cutting concern, so let's consider the example of some layered architecture. So, like in aspect-oriented programming, tries to perform some kind of decomposition of every function into different aspects, and these aspects can be concerns like security, logging, error handling, caching, profiling, etc. And now these different types of concerns are actually we achieved at system level, or which can be cross-cutting concerns, and core functionalities which actually provide the services or functionality of any system will be achieved at, we can say, at uh, sorry and these functionalities or these type of services will be achieved at the level of core concerns. So these non-functional requirements are actually achieved at the level of cross-cutting concerns, and the remaining functionality level functionalities or services are actually achieved at the core concerns. So now let's divide these concerns in more detail about what actually these concerns are. So students, in aspect oriented programming, as we discussed earlier about this notion, there are basically I give you very detail about how from functional programming we moving towards object oriented, and now from object oriented programming to overcome its separation of concerns shortcomings, we the developers community introduces aspect oriented programming as well. So functions where we have code separation is our concern, and in objects concern separation is another concern separation in our object oriented programming, and aspects are our main concern in aspect oriented programming. And these concerns are actually cross cutting concerns like logging, security, transaction performance, reliability, transaction authorization. All of these are different kind of non functional requirements which are actually achieved at the system level, and these are actually we call the cross cutting concerns. So these are the different division of concerns are pretty straightforward, and we have been discussing these terms from our last two lectures. So you should be understand these terms very well in this slide. So now we are moving toward the cross-cutting concerns in more detail. So students, cross-cutting concerns, as I said, we achieved these concerns at system level. So at system level, for example, like logging, security, and data transfer are the concerns which are needed in almost every module of an application. So hence that's why there are cross-cutting concerns. So you should note one thing is that cutting concerns are achieved at system level, and these cross cutting concerns are usually we call a quality attributes, which also refer to as non functional requirements. So whenever we design an application, so we should make use of a layered architecture. So here we can see how logging and security can be achieved at different kind of layer. So we can say in a layered architecture, if you see in this diagram, there are specific parts that are common to all these different layers, like such parts like include like logging, security, performance, auditing. So all of these are achieved at the different layers, so which are achieved at the system levels for any application. So basically most applications have a different number of cross-cutting concerns, like it can be exception handling, like it can be transaction handling and security as well. So these items do not deal with the core business logic of an application, and we say oftentimes duplicated throughout the program. So this aspect oriented approach is, we can say, suitable for encapsulating cross cutting concerns into reusable module. So this aspect oriented programming in this way actually provides us the reusability paradigm. So there are different number of libraries available like .NET framework. These are the open source and commercial. So these are actually provide different kind of reusability modules, etc. as well. So if you see about the logging example, so logging is one of the most common cross-cutting concern in an application. So like using traditional object-oriented programming, we often end with a code, like we see different examples of logging and security in terms of some example as well. So these are the different cross-cutting concerns which are actually met at the system level. Not only these are the cross-cutting concerns, there are some other concerns as well. So here are the list of some examples, like tracing, system logging is another example, error handling, different kind of data gathering about statistics, security handling, and the management of garbage collection is also a type of cross-cutting concerns. So students, all of these kind of cross-cutting concerns are usually achieved at the system level. So at the system level we are concerned with the quality attributes, so that's why these are called cross-cutting concerns. So like there can be other cross-cutting concerns like persistence of all entities, like transaction integrity, like we can say authorization of access to various services, which can be logging, security, error checking, policy enforcement, etc. So if I make it more easier for you students, logging and tracing actually helps us in our application to achieve the reliability of our application, and authentication and authorization actually helps in our application to achieve a security, and different kind of maintenance, it helps us to achieve the correctness in our application. And performance level attributes are actually concerning with the buffering, pooling, caching. So these buffering, pooling, caching are actually providing us a way to achieve a performance in our application as well. So these are the different kind of concerns which are actually achieved at the system level. So these are the different students examples of cross-cutting concerns. So basically these cross-cutting concerns are non-functional requirements, which we also call the quality attributes. So in this diagram, students, you can see that how object-oriented programming and aspect-oriented programming are looking similar to each other. I must want to clear one concept here, is that object aspect oriented programming is actually a complement to object oriented programming. We are not going to replace object oriented programming with aspect oriented programming, but aspect oriented programming provides a complement towards object oriented programming. So where they are these two terms are actually related and similar. So basically aspect oriented programming, students, works in conjunction with object oriented programming, as we discussed in very detail in our previous lectures as well. So this aspect oriented programming, we can say that is an additional technique, like not a replacement for object oriented programming. So object oriented programming provides different cross cutting concerns, and what object oriented programming has done for object encapsulation and inheritance, etc. So in this diagram on the right side, in the most left right side, you can see you can in the most left side you can see that the about object oriented programming, from where we have codes which actually describe methods in these green boxes, and while in the these blue, yellow and pinkish boxes actually represents different cross-cutting concerns or aspects in aspect oriented programming. These below box can be security constraint, can be logging, can be data transfer rates, and can be other transaction management level aspects as well. So this you can say that aspect oriented programming actually complements to object oriented programming as well. So in this diagram actually we see how these cross-cutting concerns are basically the feature of the design that may apply across all layers. So this functionality typically supports different operations which affects the entire application. So students, layered are different types of architecture we already have been discussed. So if we are thinking of a layered architecture, so usually the components from layers like presentation layer, business layer or data access layer use components that can be addressed in a common way as a concern. So which actually shows that a critical non-functional requirement is going to be met. So ultimately these cross-cutting concerns, or which are the describing with the aspects, can be like cross-cutting concerns are very much related to quality requirement as well. So for example, these different aspects can be logging, authentication, caching, error handling, localization, and communication. All of these are different kind of aspects as well. So logging means the concern which actually derives from diagnostic, monitoring, or reliability requirement. And another aspect which can be authentication and authorization. It actually concerns with security requirement. And caching concern of aspect oriented programming is actually derives from performance requirement as well. So we can say that aspect oriented programming is not a newly programming language, but it is a complement to object oriented programming. And we are not going to replace object oriented programming. The developers community just introduced this language, aspect oriented programming, to deal with one issue. So what was the major issue to introduce this new paradigm of aspect oriented programming? So the issue was object oriented programming is essentially static, and a change in the requirement can have a profound impact on its development timelines. So to deal with this issue, developers actually introduces this aspect oriented programming. So from this diagram we can conclude that aspect oriented programming is not a newly programming language, but it provides a complements to object oriented programming. So this aspect oriented programming actually deals with different aspects, and these aspects can be logging, security, transaction, authentication, etc. All of these are the different cross-cutting concerns which are actually achieved at the system level. And these different aspects are like logging, security, are actually represented by these, you can see in the left side, like blue box, yellow box, and that these pinkish box actually represents logging, security, performance. These kind of aspects are represented by these different coloring boxes, while these green boxes actually represents the actually describes our code in object oriented programming. So I hope so you will understand now clearly about how aspect oriented programming actually complements to object oriented programming. So here are some kind of benefits we also have for object oriented programming. So these are pretty straightforward. Like it provides us a concern in the centralized implementation. Code is more reusable, cleaner, and we should write less code, which is easy to understand, and it is more maintainable. Reusability and maintainability is the two important aspects of aspect oriented programming, and it also produce less boilerplate code. So what is the meaning of about boilerplate code? So this boilerplate code is actually a term which refers to sections of code that have to be included in many places with little or no alteration. So the boiler code should be less, because if the boiler code will be low, over dry concept of aspect oriented programming, which is called don't repeat yourself, will be demolished. So boilerplate code is actually bad for our system, because the reason is, the problem with boiler code is that it violates the dry rule, which called don't repeat yourself. So in the essence, we when you write boilerplate, actually you are repeating the same code or very similar code across a number of classes. So that's why the less we have boilerplate code, it will be more beneficial for us. And at the end, this aspect oriented programming is very interesting work. And all of these benefits also actually helps the developers community to achieve to get more productivity towards final application. So where we have some kind of benefits, students, we also have some drawbacks as well. So what kind of drawbacks are there while we are discussing aspect oriented programming benefits? So these drawbacks are, now the first one is about difficult to manage. So why these are difficult to manage aspect oriented programming? Because the reason is, like, few programmers are trained to understand aspect oriented programming. So the problem area is difficult to identify, so that's why it's difficult to manage. And the next one is, it is difficult to debug. Like open-ended point cut system can mean advice is being woven into many places. So that's why debugging is also a very difficult task. It also provides a limited tool support. Like it's a newly introducing approach. And few programs understand aspect oriented programming code, and even few can debug it. So the lack of tool support is also one of the drawback of this aspect oriented approach. Then the last one is about conceptual issues, like arguments that aspect oriented programming undermines fundamental structure and organizational programming properties as well. So there are different conceptual issues of aspect oriented programming are as well among the researchers and the industrial community of aspect oriented programming. So the reason is because it's a newly emerging field, so that's why there are different conceptual issues are being raised uh, with by different researchers and industrial professional as well. So these are the different drawbacks of aspect oriented programming. So students, till here our lecture number 36 is ended.